Hello there, grade 10 learners. I am glad to meet you again. Welcome to Valenzuela Facebook Live, where science learning is amazing. This is Ma'am Maylene, your virtual science teacher. Come and join me in today's learning adventure. For today's lesson, here are our learning goals. Number 1, investigate the relationship between volume and pressure at constant temperature of a gas. Number 2, investigate the relationship between volume and temperature at constant pressure of a gas. Did you know that the extreme temperature we are experiencing may cause a vehicle tire bursting? With changing physical conditions, the behavior of gaseous particles also changes from their normal behavior. The behavior of a gas can be studied by various laws known as the gas laws. In the mid-1600s, Robert Boyle performed an experiment wherein he trapped a fixed amount of air in a J-shaped tube. In his experiment, he changed the pressure and controlled the temperature, and then he observed its effect to the volume of the air inside the tube. Robert Boyle found out that as the pressure of a gas increased, the volume of the gas decreases. This relationship of pressure and volume at constant temperature is called the Boyle's law. Now let us analyze this diagram. Observe the initial condition of the gas. The gas inside the container occupied a volume of 4 milliliters with a pressure of 1 atmosphere at 300 degrees Celsius. Take note, the mass and the temperature of the gas was kept constant. Observe that when the volume of the gas inside the container was decreased to 2 ml, the pressure of the gas increased to 2 atmosphere. Remember, Boyle's law shows an inverse relationship between the pressure and the volume at constant temperature and amount of gas. Meaning, as the volume of the gas decreases, the pressure of the gas increases, and vice versa, as the volume increases, the pressure of the gas decreases. Now, if we plot volume directly against pressure, we will get a downward curve showing the inverse relationship between two variables. Mathematically, Boyle's law can be stated as P is equals to 1 over V, meaning pressure is inversely proportional to the volume, or PV is equals to K, meaning pressure multiplied by volume equals some constant K. Now, for comparing the same substance under two different sets of conditions, the law can be usefully expressed as pressure 1 or initial pressure multiplied by V1 or initial volume equals pressure 2 or final pressure multiplied by volume 2 or final volume. Now let's try to solve this problem. A sample of gas with a volume of 1.45 liters exerts a pressure of 780 torr. What must be the volume if the pressure is to become 740 torr at constant temperature and amount of gas? Here are the given. Initial volume is 1.45 liters. Initial pressure, 780 torr. Final pressure, 744, and we are going to find the final volume. For this, we are going to use the Boyle's law formula. P1 V1 is equal to P2 V2. To find volume 2, we need to derive a new equation from our original equation. So we are going to divide both sides by P2, cancel P2 on the right term, and rearranging the equation, we will get our working formula to get volume 2, which is P1 V1 over P2. Now let's substitute the given. Volume 2 is equal to 784 multiplied by 1.45 liters. Divide it by 744. Cancel the same unit, so we cancel the unit 4. And the final answer is volume 2 is equals to 1.53 liters. Now let us try to solve another problem using Boyle's law equation. A gas occupies 11.2 liters at 0.860 atmosphere. What is the pressure if the volume becomes 15.0 liters? I will be giving you 30 seconds to compute for the correct answer, and your time starts now. Alright, time is up. The correct answer is P2 is equals to 0.642 atmosphere. Now, if you think you can relate Boyle's law application in real life, well, these are real-life examples of Boyle's law. First, the mechanics of human breathing. Inhaling and exhaling basically means increasing and decreasing the volume of our chest cavity. This creates low pressure and high pressure in our lungs, resulting in air getting sucked into our lungs and leaving our lungs. Next, bicycle pump. When you pump air into a tire, the gas molecules inside the tire get compressed and packed closer together. This increases the pressure of the gas and it starts to push against the walls of the tire. You can feel how the tire becomes pressurized and tight. And last, scuba diving. As a diver descends, the water pressure around him increases, causing air in his scuba equipment and body to occupy a smaller volume. As a diver ascends, water pressure decreases. So Boyle's law states that the air in his gear and body expands to occupy a greater volume. Many of the safety rules and protocols in scuba diving were created to help a diver compensate for the compression and expansion of air due to changes in water pressure. Boyle's law explains some of the most important safety rules in scuba diving. Like, for example, ascending slowly. A diver's body absorbs compressed nitrogen gas while he dives. And as he ascends to a depth with less water pressure, this nitrogen gas expands according to Boyle's law. Now, if a diver does not ascend slowly, for his body to eliminate this expanding nitrogen gas, it can form tiny bubbles in his blood and tissue and cause compression sickness. Now, these are the applications of Boyle's law. So let's move on to Charles' law. French physicist Jacques Charles studied the effect of temperature on the volume of a gas at constant pressure, which leads to the discovery of Charles' law. Charles' law states that the volume of a given mass of gas varies directly with the absolute temperature of the gas when pressure is kept constant. Thus, when the temperature increases, the volume will also increase and vice versa. Take note, the absolute temperature is temperature measured with the Kelvin scale. The Kelvin scale must be used because 0 on the Kelvin scale corresponds to a complete stoppage of molecular motion. Mathematically, Charles' law can be expressed as V is directly proportional to temperature at constant pressure, where V is volume and T is temperature expressed in Kelvin scale. Note, degrees Celsius must be converted into Kelvin because it is the basic unit for measuring temperature in the international standards. Now, removing the proportionality symbol and using the equality sign, the equation will be as follows. K is equals to dT. Thus, in a direct proportion, the quotient of the variable is constant. Now, if you are going to consider the initial and final conditions, you will arrive at the following equations, wherein V1 over T1 is equal to V2 over T2. And this is our Charles' law equation. Now, let us try to answer this simple problem. An inflated balloon with a volume of 0.75 liters at 30 degrees Celsius was placed inside the freezer where the temperature is negative 10 degrees Celsius. Find out what will happen to the volume of the balloon if the pressure remains constant. Here are the given. Initial volume, V1, is 0.75 liters. Initial temperature, T1, is 30 degrees Celsius. Convert it to Kelvin by adding 273 Kelvin. So that gives you 303 Kelvin. Our final temperature, T2, is negative 10 degrees Celsius. Convert it to Kelvin by adding 273 Kelvin. So we have 263 Kelvin. Note, we need to convert degrees Celsius to Kelvin by adding 273 Kelvin. So let us use the Charles' law formula. In this problem, we are going to find volume 2. So to find volume 2, we need to derive a new equation. In deriving the equation, we need to cross-multiply V1 multiplied by T2, V2 multiplied by T1. So that gives you V1 T2 is equals to V2 T1. To find volume 2, we need to divide both sides by T1 and cancel similar terms. So we cancel T1 on the right side of the equation. Rearranging this equation, we get V2 is equals to V1 T2 over T1. And this is our working formula. Now let us substitute the given. V2 is equals to 0.75 liters. Multiply it by 263 Kelvin. Divide it by 303 Kelvin. We cancel similar term, or we cancel Kelvin scale. Can you compute for the final answer? I'll be giving you 30 seconds. Alright, so what is the answer? You are correct. Volume 2 is 0.65 liters. Now, here are real-life examples of Charles' law. First is a hot air balloon. The gas law that explains how hot air balloons work is Charles' law. In order to make a hot air balloon rise, heat is added to the air inside the balloon. Adding heat causes molecules to move further away from each other. The air inside expands. When this happens, the total density of the balloon and the air inside decreases. When the density of the balloon decreases to be less dense than the density of the outside air, the balloon rises. Conversely, the volume of the gas will shrink if its temperature decreases. Another application of Charles' law are gas confined in an aerosol can. So these two are examples of Charles' law. Now, for your queries and clarifications regarding the lesson, just simply type your question if there is any at the comment section, and I will try my very best to answer them. You have a minute to send us your question, and the teacher moderator will be gathering them. Alright, your time is up. I will now be reading the questions you have posted in the comment section. And thank you to our teacher moderator for gathering the questions. The question which will not be addressed today will be discussed and answered by your subject teacher in the follow-up discussion. So here is the first question from a student of Malinta National High School. Why is an aerosol can explode when heated? Take note, you should never throw an aerosol can onto a fire or leave it in direct sunlight, even if it is empty. This is because the pressure will build so much that the can will burst and explode if there is flame nearby. Next question. Why Boyle's law and Charles' law important? The gas laws are useful not only in explaining procedures in the laboratory, but it is important in addressing different situations we encountered in everyday life. Gas laws help scientists understand behavior of gases that leads to discovery and inventions of many materials and tools such as the syringe. Alright, thank you learners for sending your queries. Now for your assignment, answer Boyle's law and Charles' law activity. found on page 2 to 3 of your self-learning module. You can watch the replay if you want to look at the important concepts in today's discussion. Ask help to your parents or guardian when necessary. Your subject teacher will elaborate and explain further the concepts that you have missed in today's discussion. Albert Einstein once said, "The important thing is to never stop questioning." I am Maylene, your live streaming teacher. See you again on our next Valenzuela Live. Keep safe, God bless everyone, and enjoy the rest of the day.